Welcome back to our lesson on methods of magnetizing a magnetic conductor. We are now in the method number 4, that is the electrical method. This method is the best that it increases magnetic effect of an electric current. A coil with many turns of insulated copper wire is called a solenoid. It is used in this case. A direct current is passed through the solenoid. Let's watch a demonstration from Peter Vista.
Electrical method of magnetization. The given bar that is to be magnetized is placed inside a long coil of insulated copper wire. The copper wire is connected to a source of direct current as shown here. When the circuit is closed, a strong direct current passes through the coil of the insulated copper wire and the bar becomes a magnet. The polarity of the rod depends upon the direction of the current. If the bar is viewed from one end and the current is found to be flowing in a clockwise direction, then that end will attain south polarity. If the current appears to be flowing in an anti-clockwise direction, then that end attains north polarity. If it is a steel bar, it becomes a permanent magnet. If the bar is a soft iron bar, then it becomes a strong bar magnet and is called an electromagnet. This electromagnet ceases to be a magnet as soon as the current is stopped.
Yes, as you've observed, that's the electrical method of magnetization. Now, there are two rules used to identify the poles in this method. Let's have a look at the rules. We have the right hand grip rule. They state that if a coil carrying current is grasped in the right hand such that the fingers point in the direction of current, then the thumb points in the direction of the north pole. The illustration, as you can see in the illustration, all the fingers are pointing in the direction of current, and you can see that the thumb is pointing in the direction of north pole, meaning the other end makes a south pole. We have rule number 2, that is the clock rule. If on viewing one end of the bar, the current flows in a clockwise direction, then the end is a south pole. If anti-clockwise, then it is a north pole. Now you can see the clock rule, like now you're put in a long coil of wire of solenoid. The magnetic field line pattern is shown below. So if you view on one end, you find that the current is flowing in clockwise direction as explained in the demonstration, then it is a south pole. If you view on the other end and find that the current is flowing in anti-clockwise direction, then the end is a north pole. Note that allowing currents to flow for a long time does not increase the extent of magnetic saturation, it only causes overheating. Now that marks our end of the lesson on methods of magnetizing a magnetic material. Goodbye.